Hey everybody, this is Nick Christian with Caterpillar Global Dealer Learning. We're here in the fabulous Miami Lakes Learning Center in Miami Lakes, Florida. And today we're going to be talking about troubleshooting a -3 FMI code on a 3-wire active analog sensor. So as you can see, we've got a C15 industrial engine. We're going to be using this engine today to talk about this troubleshooting. So let's get started. So we said we're going to be troubleshooting a -3 FMI code on an active analog sensor. So before we get too deep into the troubleshooting, I want to make sure we understand when we say active analog sensor, what does that mean? Okay, active sensor. An active sensor requires power from the ECM in order to operate properly. In this case, we're dealing with a 5-volt sensor. Okay, analog sensor. What does analog mean? Analog means that the signal from the sensor to the ECM is going to be a variable DC voltage that is going to change based on the parameter being measured by the sensor. So in this case, we're dealing with a boost pressure sensor. So as this sensor detects boosts, more or less, the DC voltage coming from the sensor to the ECM is also going to vary based on the pressure being detected. So now that we've talked about what an active analog sensor is, let's talk a little bit more about what a -3 FMI code actually means and what triggers that code. So we moved into the classroom here so we can get a little bit better idea of that. So in our example we're going to be looking at, we're using the boost pressure sensor out on that C15 industrial engine we've got down here in Miami Lakes. So that sensor, just as an example, let's say it has the ability to measure 0 PSI all the way up to 60 PSI. So the sensor itself, as it's detecting somewhere in this range our boost pressure, the signal from that sensor is going to output somewhere between 0 to 5 volts. Now we don't use the full 0 to 5 volts, we kind of put it somewhere in the middle. So on the low end of the scale, key on engine off in this case, 0 PSI, if it's detecting that, the sensor may put out a signal of half a volt. On the top range, if we're measuring 60 PSI, first of all, our engine's really working good. But if we're measuring 60 PSI, the sensor may be going out to, 4.5 volts it's going to be measuring, okay? So we said an analog sensor is going to put out an analog signal that's going to be a variable DC voltage. So as we go from 0 PSI that we're detecting all the way up to 60, voltage-wise, that the sensor is going to be sending to the ECM that the ECM reads is going to be going from typically 0.5 volts up to typically 4.5 volts. So what we've got, as long as the ECM sees a voltage somewhere within that typically 0.5 to 4.5 range, right? So anywhere in here, if the ECM reads that, guess what? He is happy. He is a happy ECM, and he says no codes. All we're going to do is I'm reading a voltage, I'm reading a voltage, I'm reading a voltage. That's what ECMs like to do. They like to read voltages. And then what do? They take the voltage and they equate it to a pressure, right? In this case, based on the software, okay? So an FMI-3 code, the description for that code is voltage above normal, okay? What's normal? Normal to the ECM is he's happy, okay? If the ECM detects a voltage above normal, so anything above this 4.5 range, this is where we trigger a -3 FMI code. FMI being failure mode identifier. So it's giving us an indication as to what the failure mode that it's detecting is. In this case, voltage above normal. So now that we understand what a -3 FMI code is, we've got 5 suspects that could be the root cause of the problem. So it's kind of like we're playing detective here, right? What are the 5 suspects? The power wire to the sensor, the ground wire to the sensor, the signal wire from the sensor to the ECM, the sensor itself could be failed, or the least likely, the ECM has failed. All right, so we're ready to begin troubleshooting. Step 1, any problem that we have with any active sensor, the first step is always going to be check for power, okay? So on this 3-wire sensor, on the A wire is our 5-volt analog supply coming from our ECM. The B wire is our return, also provided by the ECM. And the C wire is the signal from the sensor going to the ECM that's giving us that variable DC voltage that we're looking for. All right, so we go to check for power between pin A and pin B on this 5-volt sensor. What we should see is 5 volts, plus or minus half a volt in this case. So we're seeing that here. This tells me that this active sensor does have the proper voltage coming from the ECM. So what does that do for me? Our 5 suspects, power to the sensor, ground to the sensor, guess what? Those 2 off the list. They are not the cause of the problem here. We're down to 3 suspects that could be the root cause of our problem here. It also does something else for us. We're gonna create a short circuit condition and try to flip this code, and that's gonna tell us something also. The B wire that we just validated, we can now use that as a ground to short out our C wire, which is the next thing that we're gonna troubleshoot. We can easily validate at this point whether or not the sensor is the root cause of the problem or not. The way we're gonna do that is we're gonna take the sensor out of the equation, we're gonna set the opposite condition of the code that we have and see how the system responds, okay? So if I open up our sensor here, so he's completely out of the equation now. The opposite condition of a -3 code is a -4 code. That is an FMI -4 code. That is a voltage below normal condition. I can make that happen, okay? And how am I gonna make that happen? Magic. A little short jumper wire here, okay? And what we're gonna do is with the sensor out of the equation, okay? He's not in play here at all. We're gonna go ahead and take that signal wire, the C wire, and we're gonna short it by applying the sensor ground, the B wire that we already validated, and cause a short circuit between B and C and see what happens. So we've got the B ground wire and the C, the signal wire. Now we wait. So we've waited a few seconds now. Every code's gonna be a little bit different based on the software we're dealing with, even based on the sensor that we're dealing with. So this time that we need to wait to see if the code flips can be 3 seconds, can be 5 seconds, can be 10, could be up to 30. It really just depends on that software that we're dealing with and the sensor that we're dealing with. But if we've waited enough time, what we expect to happen, I've made a short circuit condition on this signal now. So the ECM should be seeing a voltage low condition. Okay, so I've made a short circuit. If the ECM then at this point tells me that it's seeing a -4 short circuit condition, voltage below normal, okay, what does that mean? I made a short here. From this point all the way back to the ECM, it's doing what I expect it to do. So let's think about that. I have a short, the ECM tells me I have a short. I remove my short circuit. Okay. Now, if my -4 code disappears and my -3 code appears again, when I make an open, the ECM tells me I have an open. When I make a short, the ECM tells me I have a short. So, who's the odd man out here? The sensor in this case would be the root cause of the problem, because when I plugged it back in, I still have a -3 voltage high. So what happens then if we made our short circuit and our code does not change to the -4, right? So we've waited our debounce time. Code still is an active -3 code. So in that scenario, I've made a short circuit at the end of the harness, but from here all the way back to the ECM is still telling me it detects a voltage high condition, right? An open circuit most likely. So in that scenario, what does that tell me about the sensor? I've taken the sensor out of the equation. I've made the opposite condition at the end of the harness, but yet the ECM still tells me I have an open circuit condition. So in that scenario, I'm pretty sure that my sensor is okay because I took it out of the equation. The system is not responding the way I expect it to. So the sensor is not the issue. So I took out the A wire, the B wire, not suspects. In this scenario, the sensor is also not a suspect. So who's left? The signal wire or the ECM? That's the next place we're gonna go. So in this case, it's easiest for us to go ahead and troubleshoot the ECM. So we made the opposite condition out at the harness with the sensor not installed. We're gonna use that exact same logic, only now we're gonna do that at the ECM. So first thing I need to do is look up the schematic for my engine here, okay? So we need to find out where does our signal wire from the sensor enter into the ECM? Which connector, which wire do we go at? So we've identified that. Next thing I'm gonna need is a wire removal tool. Hey assistant, can you help me out on that? Ah, thanks assistant. Good old handy wire removal tool. So we're gonna go ahead and remove that signal wire from the sensor that comes back to the ECM, we're going to go ahead and open it up. So this is our signal wire from the sensor coming into the ECM. Now, I just made an open circuit condition again. So what would have we been talking about with a -3 open circuit? If I make an open, I should get a -3 voltage high code. Except for that's the code that we started with. So really, you know, the ECM should be telling us that we have a -3 at this point. That's what we expect to happen. So if I want to test the ECM at this point, I'm going to need another prop. Hey, assistant, you got me a jumper wire? Ah, thanks, assistant. So we got a jumper wire here. We're going to install this wire where we pulled out the signal wire from the sensor. All right, we're going to give it the good old 10-pound pull test, make sure it's tight. Yep, it's in there. All right, so now we're tapped right into that pin at the ECM. To create the opposite condition, now we want to short circuit that pin, and we should expect to see a -4 code come up after a certain amount of time. So we moved a little bit of paint from this bolt here. This will make a good enough ground for what we're doing. So if we go here and we create a short circuit on that pin at the ECM, I've made a short at the ECM. What do I expect the ECM to tell me? Well, if I've made a short, I should expect it to tell me I have a short. So a -4 FMI code, voltage below normal, indicates that I've made this short circuit condition. So again, I'm going to wait that few seconds, maybe a little bit more if I need to. If the ECM tells me I have a -4 code, it's sensing the short circuit that I just made. And then if I let that go again, and that -4 code goes away, and the -3 code appears again, well, if I have an open circuit, -3, if I make a short circuit, -4, so I'm just exercising the diagnostic capability of the ECM. If the ECM is doing what I expect it to do, who's left? The signal wire between the ECM and the sensor, that's the only suspect that's left. I could go through, ohm that out, and I would expect at that point, based on what my troubleshooting has been, I would expect to see an OL, an open line circuit here, and see no resistance on that wire. So let's flip that around. If I've made my short circuit here at the ECM and I wait my several seconds here, but I still have a -3 code, right? Voltage above normal, even though I'm shorting out that circuit on the ECM, well, this is kind of a rare occurrence, but that would tell me that something inside the ECM is open circuited, okay? We can't go inside the ECM, we can't troubleshoot the internals of the ECM, try to replace the ECM or put on a test ECM if that fixes the problem. I always want to validate and put back the old ECM on. My problem that I have should immediately come back again, and that's a real good procedure for replacing the ECM. All right, everybody. Hey, thanks a lot for watching this video. I hope you enjoyed it. I had a lot of fun making it. If you're interested in more electronics troubleshooting, we're going to be making more videos, so stay tuned to Electronics on Channel 1. Also, if you're interested in coming to a class down here at our Miami Lakes Training Center, we do offer a full-week electronics troubleshooting course where we go through this scenario and a whole lot more. If you're interested, go here and search for course number 52647. It's called Electronics Troubleshooting. I'd love to have you down here for class and answer any other questions that you may have on electronics. So good luck out there troubleshooting, and remember, if you're nice to the electrons, they'll be nice to you.